record. Okay. That way you guys will get this video sent out to you guys in your emails and so on, and you can refer back to this demo later. After that, I went to that was in St. Louis. After that, I went to work in Nashville. I had a really fun indie on Dawn of Defiance, and this is a really great example of in some of the previous games we did a lot of proceduralism and a lot of like kind of shader and environmental sports. This one is a lot of the type of things that we'll be kind of seeing today, where all pretty much everything here was kind of built in Houdini. We were the environment art team, especially the organic side of things, was pretty big into Houdini. So all the terrains, I worked on the oceans for this. A lot of cliff generations, the foliage scattering. So worked on inviting some support there. I was the only tech artist. We had a tech animator, but I was the only tech artist there. That was really fun. Little Jube. And then there was a big round of layoffs. I think that hit the industry about a year or so ago, year or two ago. And then I started teaching here. And then about a year ago, I started at Meta. Okay. So about the program. So kind of our goal is to do a couple things. Our goal is to first and foremost give you like some practical skills. We want you to be familiar with certain DCCs. And if I keep using that term, that's digital content creation tool. It's just a fancy word for like Maya, ZBrush, Houdini, whatever, right? It's the tools you use. So we want to give you the practicals. Here's the button to press. Here's the nodes to do this. Here's how you do X, Y, Z for the job. But we also, a tech artist is a unique role. You're basically helping the artists have a great, beautiful life. The artists don't want to spend all their day troubleshooting technical BS. They want to be creative butterflies, and your job is to help them break free of that cocoon of all the, everything that's holding them down as much as possible. So in some cases, you might be building tools for them. You might be just helping them do look development. You might be working alongside them and building some part of the art that's just a little too technical for them. So you need to have a certain amount of background knowledge, okay? And also you need to be able to communicate, because you're kind of a bridge between the art team, usually a group of non to medium level technically inclined individuals, to the engineering team, the programmers who are very highly technical, and sometimes they don't left brain right brain type thing. They don't speak the same language, so you have to be able to communicate between those parties and be able to communicate why something might be important from an artistic perspective to the engineers, and explain to them, hey, why does this feature really matter? Why should this be important, and focus our time on, and kind of vice versa, kind of explain things that are very, very technical in nature in very, very simple language. So communication is really key, but also knowledge is really key. The artists are going to look to you as a kind of a resource to know if something's viable or not. Oftentimes, a designer or a director might come to the tech art team and be like, hey, we had this really cool, crazy concept. We have, it's a boss and they're entirely made of fire or whatever. Can we do this? Right? Is this technically feasible? You have to be able to answer that question. So we want to make sure you have certain technical knowledge, and in the area of computer graphics, quite obviously. So, and the area of programming, and also maths, because maths is fun. It's beautiful. And really it all kind of works from there. One thing I'll say about that is, like, I didn't like math, or I thought math didn't like me as a kid and in college. But when you're playing around in like a node network, or in like materials, or in particle effects, you can get a good looking thing just by playing around. But it really helps to know what you're actually doing, and that's one thing math can give you. And you'll find, especially through the course, that math can be a lot more intriguing once you realize it's like a key to making beautiful things. So we try to structure the course in a way where you're kind of picking up some of these things a little bit by osmosis. We're really more concerned with you using some bit of programming or some bit of mathematics as a tool, as a what less than a how. This isn't a calculus class. This isn't a class on proofs. Oh, this is a class that is vocational. It's oriented towards you, getting some skills to help you get a job. So we want you to think, oh, alert, here's what I can do with that. It's less important that the mathematic, the full proof of the mathematics behind it, though we eventually build up to that by the time you get to term 4. But this is a blending operator. This lets me blend 2 colors. Okay. Dot products. I can use that to compare if vectors are similar or not. So we want to kind of know what, you can blend textures with it. You can do all kinds of things with linear interpolations. But that's the case, across the board. So yeah, this is kind of that same kind of slide here. So really more on the what you can do with it, kind of treating these things like an artist, like just a new brush in your toolkit. Okay. We'll have 2 days for this, like a set of slides. It will be kind of a lecture, more of a technically oriented lecture on like this one says Tuesday, Thursday. It really depends on how the class is scheduled. Sometimes they're Monday, Wednesday. And then on that Wednesday or that Thursday is going to be a demo, and there'll be recorded lectures, and this is usually going to be the type of content you're going to be covering in your recorded lecture as well. On request of the how everyone's doing, sometimes we'll add a third day as a homework lab, just an additional, usually on a Friday, for people to come in and just kind of all work together and share screens and kind of get through some part in the content that they're struggling with, because the stuff, we can go a little fast and the stuff can be a little challenging. Houdini is what you'll need when you pay for the course and all. You'll get a license. You'll get an education license, which is a pretty souped up license. You get like all access to everything with that. Unreal Engine, that's free. Substance Designer, I don't think that's included in there, but that's with an Adobe license, that's pretty there. As far as programming environments, really you can program in like a little bit of whatever, but for sure we do a lot of examples in something called ShaderToy, which is like this online graphics like kind of shader compiler that just it's very easy to share and to just get things going right off the bat. You don't have to build a whole 3D render engine. You could just like go to the fun part of writing the shaders. So some kind of text editor usually is helpful, like Sublime Text is what I would recommend. And also there's some other IDEs like Visual Studio, Cursor is popular, VS Code. You can use one of the JetBrains ones. It's whatever. All right, awesome. I think that's it. Do we have any questions before we go into a demo? Do we want to see some fun things today? Any questions on the structure of the course or me? Awesome. I love no questions. Okay. Okay. So we're going to kind of walk you through how you might go about building a small little scene of something kind of like this. Okay. So we have a little scene here where we have a little bit of terrain. We have some scattered assets. And, we have some applied textures. And we also have like some inset little meshes. Okay. And none of this was kind of built by hand. Okay. This was all kind of done procedurally. Okay. So we'll come back to this when we get to materials. And right now we're just gonna kind of hop into the Houdini side of things and play around. Okay, right off the bat, this is Houdini. Now, when you open it up, it's not maybe gonna look like this. It's gonna look I think it's build usually. Yeah, so this is how it's usually going to look. Right. I'm not going to spend a lot of time going through, the whole UI. I'm just going to kind of do the demo. But long story short, what we really care about in this tool, the viewport's important, especially, but a lot of times we're not really doing things in the viewport. You totally can, though. You totally can still. It has all the same modeling tools, all these other things. You can manually work in it. You can work destructively, but we're really wanting to understand the procedural workflow. So we really care about this kind of node network down here. Okay, so this is kind of like these nodes. All right, so we have these different contexts in Houdini. Okay, so if I click here, you can see these. There's a material context, there's an image context. That's kind of like Substance Designer. It's all kinds of things here. But this object one is kind of like our main scene. Is, you know, if you know the difference between like the edit mode and the like the object mode in Blender or something like that, it's kind of like this, where this is like where you might compose scenes. You can put cameras out here, whatever. You can put lights up. But I'm gonna drop down to geometry. If I hop in here, now we're in like the geometry context, and here I can create geometry. I'm gonna drop down a little test geometry. This little toy, or and I have this same little toy right here. It's cute. They actually were giving this out at GDC at the side effects week. So it was really fun. This is one of their test geometries. Another one, which might seem a little bit more morbid if you've never seen this one before, is like this pig head. This was like a famous computer graphics like standard for like testing subsurface scattering. So, but this is really, really popular to use in Houdini. So I think it's the only tool that really kind of uses this one. So I have a little pig head too. It's kind of fun. But you know, this is where you would work with geometry. And in here, in here, if I hit tab, we have all the same kind of modeling stuff. So if I do like, we have poly bevels, we have ability to cut, we can extrude, fill, we can do all the things, okay? But really what we want, so if I click on these nodes, you'll see this stuff up here changes, right? This is like the parameter panel, this is the network. Really, I don't want this. What I want is just as much network space as possible. And I can hit P and it's going to give me like a dynamic one, okay? This is kind of the gist that that you're going to want, okay? Something kind of like this. I already have like a desktop preset that I'm just going to change to, which is kind of the same thing, but I have a couple other windows set up here and there as things matter. Okay, so basically, you can build things here, okay? So we'll start by just building something kind of somewhat simple, maybe like a little wall or some kind of, you know, a little piece of geometry, and then we'll kind of go into something really fun like terrains. So one thing you can do is, let's say I want to make a little garden wall. Let's try that. I'm just going to drop down a little spline, okay? And curve spline will be fine. And I'm going to set my viewport to top for this. And we're just going to click a couple. You know, I actually prefer a polygon. I think curve, if I type in curve, just a normal one. This will drop polygons instead. Okay. All right. I'm going to hit enter. And okay. So basically we have this little thing here. Okay. And I'm just going to use this as a starting point. Okay. And drop a little null here. It's just like empty. And what I'm going to do is I'm going to assume everything past this point is going to be like a tool. This was going where I'm going to treat this as an input that necessarily could change, right? So what I'm going to do is I'm just going to say, ultimately what I want to do with this guy is I want to like turn this into a piece of geometry. Okay, so I could transform this guy. Let's say we transform it some amount. And what I want to do actually is I'm gonna drop down another little null. This guy right here, I might call this in curve, okay? Because you know that's just where there's a curve coming in, okay? And I like to just make this white and use this little shape. Okay. And I like to drop another null here. And I'm gonna call this a control. You could also call this parms. We'll just call it parms. It's short for parameters. Okay. And I'll make this a circle. And we'll come back to this guy in a second. Okay, let's say I have this guy kind of moved up 7. That's fine. And I'm going to drop down a merge. I'm going to take this previous setup and this setup. I'm going to do that. And I'm going to drop down a skin. Okay. So we have 2 little wires, and we can kind of skin these guys. And we've made a wall. Okay, wow. Weak. Okay, but obviously this is kind of like, you know, we're not really interested in making something from like 2004. We're interested in maybe something that looks a little nicer. So this is the non-destructive. I can go back up and I can make changes. So I want to like take this incoming curve and make it a little bit more smooth. So what I'm going to do with it is I'm going to convert it into a poly spline, which basically gives, this is like a node that gives me like different types of cool mathematical splines, like Bezier splines and things like that. I like this one they call B spline. Usually if you set the endpoints just a little bit further out, you get more of a smooth interpolated curve, right? And I can click here to preview what we had before, okay? And if I click up here, I can click here and I can kind of move these guys around, and we can see that these CVs, these control points, that's my main curve. Now I want to resample this curve just so that we can have a decent control of the amount of points. And also, one really cool thing in Houdini, I'm gonna turn off my palette real quick so we get a little more space, is you get like absolute control over all the data. It tells you everything. So like we can see those points right here. Okay. We can actually even see the number of points we have. Okay. Every single point has a index set to it. And down here we have something called the geometry spreadsheet. And if I middle mouse click on these guys, it'll tell me data about these, an attribute. Okay. This is kind of like some orientations here. So this is a point attribute. This is a P. Okay. And we can look here and the P dot Y, we're Y up in here, it's 0, right? It's on the ground. So this one we moved up and we can see that data has changed for all those points. Okay. That's really simple for that now, but you can actually drive things based upon what's happening at every single point, or primitive, or in this case, a primitive is like a face or edges or so on. So what I want to do is just in here, I can set this to like an edge length, or I can do like a maximum number of segments. For right now, we might just set it to like maximum segments 50. I might just keep that as it is. And what I want this to do is, this is a back face. So I'm going to thicken this guy. I'm going to just use this thicken node. And what I also want to maybe try to do is get rid of some of this geometry where I can. So I'm going to dissolve some of these flat faces. Okay. And now it's fairly curvular, so it's not going to be able to dissolve as many of them. But let's say I went back up here and we made this guy like quite flat. All right, it would try its best to minimize some of that, which might be good for us. Now you might notice we're getting some weird little topology and normals here. Don't worry about that. We can always change that later. That's one of the really cool things about Houdini, is that really everything's kind of live. So for example, I'll drop down like a face weighted normal here, right? And it would entirely go away. So we don't need to worry about it. We'll just run that down. So what I want to do is I just want to do a little bit of fracturing, and also I want to create a door. Okay. So I'll drop down what we call a Veroni fracture. And Veronis, if you're familiar with that, maybe ever used in a substance. Anyone familiar with like Voronoi or a Veroni texture or noise? Anyone familiar with that? Yeah, like cells, exactly like cells. So Houdini also has like a substance designer kind of context. So we'll just go in here so we can kind of see what we're talking about. If I drop down, I think in here it's called fractal noise. That's called Worley noise. And I'll set this to the composite view, which is like the 2D view. Okay, so this is like a Veroni type of map. And really, it's just a type of noise that you get from having a bunch of distance fields of spheres. So you have a bunch of points here, and every point has a little, radial gradient, and they kind of meet and give these little, almost like little spider webs. These are really cool. We can use these guys when you're doing texturing. It's really useful to create all kinds of organic patterns. You can use them to create cracked deserts. You can use them to create the patterns on like dragonflies, scales. You can use them to create destruction elements or rocks and so on. one thing I'll point out is right here, for example, these textures right here were actually created using a Veroni kind of pattern. Okay. So that's kind of what a Veroni pattern is. All right. But we're interested in seeing this kind of thing in 3D. All right. So this guy wants a set of points and wants some geometry to fracture. This will kind of break things up. So we'll click back here. All right. We need to give it some points, and we can do this a couple different ways. I'm gonna do a scatter stop, a really cool stop that just scatters points. Boop. Okay. Or turn off some of these visualizers so we see a bunch of points. Okay, they're fun. And I'm just gonna lower this count to like 100, and we're gonna run that into here, and then we're gonna run the geometry into here. Okay. And then we get these kind of fractures like this. If I were to drop down exploded view, we can see that there are separate little pieces. Okay. And if I come back up to thicken, maybe I want this wall to be a little bit thicker seeming. Okay. All right. Well, it's having a little bit of a tricky time with that. What we might do is we can just bypass this guy for right now. I think we made it a little too thick because it was collapsing on itself. That should be fine for right now. And we'll go both directions. Might as well. That way it's even Stevens. Okay. So we have all these little, like almost like little rocks here, right? And as I increase the number of points, we get more of these little rocks, right? Okay. That's great and all. But already, going up and down, clicking every single menu might be a little bit exhausting. Okay. So instead, what I might want to do is I might be more interested in having one menu that I can kind of control everything with. Okay. And that's what this little thing is going to come in handy from. So I'm going to right click here. I'm going to go to parameters. And this little window pops up. Okay. What I'm actually going to do, I'm going to add another parameter panel right here. And I'm just going to pin this one so that this one will kind of just stay here. And we can kind of just come back to this and change settings. But we're going to edit this guy. We're going to add some stuff to it. And we'll go ahead and add a folder here. We'll call this guy, wall generator or something like that, something fun like that. Okay. And what I care about, let's say we care about the height. That was fun. So we'll make that a float. We'll drop in a float here. We'll call it height. And let's see, we wanted to control how many points we have here. This is an integer, so we want to drop in an integer. And call it numpt. And I'll call this like fracture points or something like that. And just so things don't go crazy, I'll set a maximum, you can set a range here. I'll set a maximum limit of like, I don't know, 3,000 might be fine. Really, with a good computer and so on, you can go crazy, but I just keep things going fast. And we'll set it to 100 as default in here. And for this guy, maybe a similar kind of idea. 0 to 110, that's fine. And we'll set default to 7. Okay. And let's see, was there anything else here that was fun? We could maybe add this guy, but I think for now we just won't even bother. Maybe we will do the thickness, right? We'll kind of think of our wall thickness, okay? We'll have that as a float, okay? And call this thickness, or just thick for short. Okay. And just we'll give it a little bit of style. We'll drop down I'll go ahead and apply so we can kind of see what's getting in here. We have this little bit of a menu here, but I'll make it look a little bit prettier. Set that to simple, and we'll drop a separator in here. Just so we're separating our things. Let's set a default value here of 1, and I don't know, maybe set like 3 as the maximum range. Now, when you click this lock here, it makes it where like it's actually clamped it there. Otherwise, it just sets the GUI. Apply, hit OK. Now, what I can do here, I'm gonna right click this guy. I'm gonna go copy parameter. And if I go over here, I'm gonna right click and say paste relative reference. And now it's done a really interesting thing. So what's really cool, a really powerful thing about Houdini is that every single button is not just like a parameter or a setting or a slider. It's what we call a channel. Okay. So it's there you can link things together, right? And I can even turn on this little thing that shows, I think under view, show for all nodes. It kind of shows what nodes are linked together. Okay, so now that I've it says ch channel and it references this node's name and like that its parameter. Okay, and I can click it again and we'll just see the number. So as I move this guy, we see this guy change, and we get more of our little things in here. Very cool. That's great. Now, these channels are powerful. We can do all kinds of things. We can keyframe these channels. We can do math operations in these channels. There's actually a whole context where you can just add procedural noises, almost like a synthesizer, and do things. You can do all kinds of wild things. So we're just going to link some things up here. Copy this guy, add this to our transform right here. Paste, relative reference. That's great. And here's another example of how we might do a little parameter. So our wall thickness right here is 1 across. But if we remember this thicken node, which is really this right here, by the way, is what's called a labs node. So the people at Side Effects who make this tool have a special internal team that kind of makes small little game projects, and they build little helper nodes that's kind of oriented towards those type of things. And you'll notice this guy has a lock on it because what it's called is an HDA. It's a self-contained little node. If I drive in here, we can actually see how it's made, right? And it's made of 2 extrusions, poly extrudes. So it kind of just extrudes both sides. So this number here, when we set to both directions, right? Really, the thickness is not 0.5. The thickness is going to be 1, right? So what we want to do, just so that this, when we're giving a tool, we want it always to be intuitive and human languageable and have like human language, I guess. We can right click, paste relative reference, makes it much thicker, but I can just divide by 2. And now it's going to be like we want. And it's like a little math equation, okay? That's fun. That's fine. What we might do now is drop down a little null. I'm going to call this out wall. Okay. A lot of people like to make these like X's. I prefer to make it like this, but everyone usually makes it black. And I'll drop this right here. And what we want to do, I'm just going to drop another thing like this. I'm going to select all this stuff right here. And I'm going to hit Control C. Sorry, rather Shift C. And what this is going to do is going to put this all in one node. It's called a subnet. Okay. And this is kind of the first step to making a tool. All right. So what I'll call this right now is my wall maker, wall gen, or whatever. Right. Okay. And I'm going to dive inside. Okay. And we're just going to keep going. Okay. So what we want to do, because if I set this to like smooth shaded, you wouldn't really know anything's going on at all. So what we want to do is we want to get all these edges that we have, and we want to kind of do a little bevel maybe, and could potentially even do a subdivide or something like that, right? But what's going to happen that's going to be a problem with that, if I drop down like a poly bevel, okay, well, you can kind of see that kind of is doing what we want, okay, a little bit, but one, we don't want it to be round. We probably just want it to chamfer. You can kind of see there's like some weirdness going on, and that's because this, if I set this back to wireframe, we're getting a bevel across every single one of these wires. It really just grabs every single edge here. So what we want to do is use a group. So every node here will have this little thing called a group. Think of a group like a mask. This is like a mask based on some data or whatever that we can actually use to just have this operation only happen to this. So what I want to do is actually, instead of dissolve all these guys, because it's all going to be super curvy, what I can do is I can just grab all these guys into a group. All right. I'll drop down a group. And I'll call this I don't know, um, initial edges, whatever, it doesn't matter. Initials, what I might call it. And we can have different types of groups. In this case, I care about edges. So now if I went down here, you'll see that if I click here, now that initial group shows up. It also shows up in all these primitives. One cool thing is that it will sometimes convert groups to things. So here it says guest from group, but we want this to set to edges, and we get these that initial down there. Okay. But if I were to set that one, right, say I scroll all the way to the bottom and click that, and what I might even do for right now is this is outputting like some different groups and a certain attribute called piece. So like if I middle mouse click on this, we have some we have let's see, we had this primitive piece, the middle mouse click here. You'll see that shows up here. So every single one of these guys will get like its own like number that goes to where it is. And that might be useful later. But for right now, let's turn that off so that it's not cluttering up our menu. And we'll maybe also get rid of the name attribute, which I think is also doing the same thing. So let's go attribute delete. Let's get rid of this real quick. And yeah. Okay. No mouse click. We're just seeing normal, that edge group, and these are attributes and these are groups. Now, groups and attributes are the same kind of thing. The only difference is that like a group is just like a simpler attribute. It's just a like an integer that's 0 or 1. And then you can actually see it in the geometry spreadsheet the same way. You just turn on a group attributes. If I go to, I think this was this is an edge group, so actually you can actually view it because edges are not first party data types. So, but this was, say if I made this a points or whatever, it would start to misbehave. But we come on here and I can set this to group attributes. You would see group initial and it would be 0 or 1 or whatever. Okay, I'll set this back to edges. And what I'm curious about doing now, what I really want to do now, I'm going to go ahead and cut these lines with Y to cut, move this stuff over here. And what I want to do is I have a group, okay? And I can actually see this, visualize the group in the, I hate this thing, get out of here. We can visualize the groups. I'm gonna right click here, set this to edges, and go to selection, go right here, and click this little guy, and it will show me my groups. So we have some groups coming in, say around here, so at all these little groups. And you notice when this guy came through, I decided to like break some of my groups. So that's fun, but it's fun. Well, really what we want to do is we want to get these lines that are coming down, okay? And we want to get the new ones and then just subtract basically the groups that were there. One thing we can do is try to do a group transfer. Sometimes an operation might intersect, especially edge group. Edge groups are kind of finicky like this. I'll try a group transfer to and from. And let's see if we get these guys come back. I only care about edges. And we're going to grab this guy. Let's see if we're able to get those guys. If not, that's fine. We can do this the harder way, which is just that we set these as a point group, which will usually maintain. And we just set this to points, and we'll see that they all exist there. Okay. Okie dokie. And now we have all these extra points. So I'm gonna drop down another group. Well, this right here is fine. I'm gonna call this all. I'm gonna set this to points. And what I can do is I can do a group combine. All right. And this basically lets me do like Boolean type of, operations with the groups themselves. So I can start with my all group and I can subtract equals the all group, but subtracted with the initial group. And let's see, we want this to be called something else besides all. We'll call this maybe rocks or fracture. We'll call it fracture group, fracture points or whatever, right? if I middle mouse click, we'll see there's numbers down here. This is the all, and it's 1,556 and the 204. So these are different numbers, right? And I come in here, and I think this might work with points, but usually doesn't work super well. So if we set this to fracture with the fracture group, it's doing something, but not quite what we want. But we can convert groups. So I'm going to do what's called a group promote. And the idea here is that we can take this fracture group and we can convert this. So the cool thing in here is if you have data of one type, if it's on points, if it came in through a texture, we can always convert it to something else. We can convert it into texture spaces, into for faces, for primitives, whatever. So I'm gonna set this to edges. And we're just gonna set this to visualize. All right, let's just see what it's doing. Include only on boundary. Okay, so it's going to be a little difficult with this. Okay, that's interesting. Okie dokie. So what we're going to do here instead, this is funny enough, this is usually the type of, when you're using Houdini, the type of thing that usually takes you like the most time is like figuring out how to get a good data structure to do an operation later on. What we want to do is we want to take this thing right here, set this to edge, right? And we want to just kind of do something like this, right? And I'll just go ahead and visualize that. So we have just enough of a facet there that these guys will stand out. So when I set this to smooth shaded, right? We have a starting point. And then at that point we could do interesting things, right? Like we could do other things. Well, what might be a good idea is something like this actually. This might even work better. We'll set this stuff aside. That's one approach. But what might even be better is just doing it in a loop. So, like programming, when you program, you can do things in like a little for loop, okay? We can do that here. So I'm gonna drop down a for each connected piece, right? So we could do a for loop for each point, primitives, whatever. In this case, we're going to use this thing called connectivity. It's just going to set a little attribute called class that will basically detect if something is like the points are fused or not. So if I drop down like a null, just so we can kind of visualize what's going on inside our loop, I'm going to turn off all these wires because it can be a little distracting. I like to set this to just just select a node. Okay, so that way, this guy right here. And what you'll see is that we just have the one little guy here. If I come down here and we can just set this to single pass, and if I do this, you can kind of see, oh, here's another cool thing. I might have glossed over this. Any single slider here or whatever, let's say like with transform, if you middle mouse click, okay, you can go up and down and do like by a big number or by tiny intervals. That's like one really nice thing about the GUI here I'm a fan of. So in here, okay, now this might be like a little bit better of a space to kind of do some of this get rid of some of these edges. So what I might do instead is I might do something like this maybe where we have this initial be like a primitive group, right? That could be interesting. And let's say we just visualize that primitive group. I may have gotten blasted out of here. Funny enough, let's see what we get out of here because sometimes we get good or interesting groups as well. Now, here's another fun thing too. We had this primitive called piece. This thing called class here, when you set this whole thing down, it's running over primitives and it has a piece attribute called class. So technically, I didn't even need to make this. I could have totally like just deleted this and delete this channel and instead use the attribute that we actually have here called piece. That works just the same. right? So works just the same, right? Okay. So in here, I can actually do my poly bevel, right? I'll set this to single pass, but we will go ahead and get rid of the group. We'll just kind of see how it's deciding to cut things up in here by itself. We'll turn off some of these visualizations. Okay, not awful. Okay, so this was kind of one of those things we want to get rid of. Luckily, though, we did have some things here that we can work with. So we had this outside group, which was basically like the outside wall, and those are looks like a primitive group. So we could maybe try to convert these from some kind of we could try to maybe convert all these to edges. But one thing that's neat or unique, right, is that you'll notice that like the wall doesn't like bend over, right? It's upright, okay? Meaning that the surface normals on this wall are always going to be like X or Z oriented. So that's really useful because the group SOP, which we just like had it just do like the fill, it can do a lot of cool things actually. It can you can I'll kind of show you a couple of fun ways that you can add things into like a mask here. Set the points because I'll make it a little bit more easy to show off. Turn that off and turn on this visualization. You can do like a bounding object, right? So like a box, right? Fun it, right? And then these are all getting collected into a group. You can even use like an input object, right? So like if I had like that pig, right, from before, right? Now this needs to be a closed geometry. So I'll set this to easy, which is a closed geometry. And if I scale this guy up enough, we'll see that right, it collects those. Can sometimes be a really clever and easy way to get groups because you could have something that generates things, or I could scatter points, right, and then copy like something to those points. Anyway, I'm more interested in this one, keep by normal, which so we can use the direction of let's say up, because that would be the direction that we're not concerned with, and we can kind of do something like kind of like this, right? But we care more about the edges right now. All right. And we can do union with existing. And we can also do this inside. So we might do it out on the outside, might be more interesting. All right, so you say with just a little bit, you'll notice that all the up and down lines are pretty much Gonzis, right? Trying to make sure we didn't. That one is one we didn't want to lose, but it probably should be fine regardless. So you'll notice that the only ones that are getting selected in here are kind of all these little cut up pieces. Okay. Um, okay. Now we could also play around with just like oops. Oops. Seeing what else that we might be able to do just by doing it the opposite way. And here I kind of like this one a little bit. You see it's kind of filling things out, but you'll notice you do kind of get like these up and down ones. So we'll just keep it as like this. Um that's fine. But what we probably do want to do is we want to bring some of this stuff back. So uh let's call this sides, and we'll call this we might want to do one that's like top and bottom. Uh what ends, I guess, or whatever. And for this one we could just do it like the same kind of idea. Uh but both ways. And really what I'm trying to do here, I don't care about what happens right here. I care about what's happening right here, that I get connections, but try not to get the long pieces. Again, this doesn't have to be perfect for the type of system we're building here, but I'm just trying to get something where I can I can kind of get somewhere with it. Okay. And we want another one that's just going to be all. All, and we'll just do all and intersect that with what is it called? Sides. Instead of fracture, we're just going to do sides. And we can actually do multiple combines. So I'm going to do ends, I'll do all, and same kind of idea, intersect with ends. And now we'll create this guy by making it equal to ends plus sides. So an intersect basically just means like where both of these show up together. So like that would mean that if I, let's say we just looked at like the sides here, it would just be whichever ones happen to be the same here. Basically, we're trying to kind of eliminate the top before we add things together here. Anywho, we could also do this by subtraction. That could work as well. But this will probably work more or less for what we're trying to do. We'll pass that in here. Actually, we need to. Yeah, we should be good. This is all edges. Close fracture. And we did call this fracture. Copy. Okay. And it looks like things are looking not too bad. All right, so now you're noticing that we're not getting that bevel across all these little other edges. That's great. That's great. We are getting a little, we might do a second chamfer just because it might help. One thing that, because we're noticing a little bit of weirdness going on right there, right? So what always helps with that for me is like just be able to actually see what's going on. So we have the piece attribute. You can actually turn on a visualizer. So this is piece number 320. What is that? 9? And it's being super weird, right? So let's 329, let's get to it and see why is it being that way. Okay, it's oh, it's got some weirdo things going on here. So what we could do sometimes could be just the way an edge is splitting, right? We could just make sure that we yeah. So because this one didn't get added here, I think it didn't grab this rest of the edge for some reason. That got lost. So what we're just gonna do is we're gonna do something like this, and we're just going to fuse. What we're going to do in a second will kind of solve for any kind of weirdness. So it's not super going to matter because we're about to take this into a volumetric space. But just in case we'll do something like that. And that might help solve any kind of weird Z fighting before we get too deep. Okay. So looks kind of whatever. We'll bring back our face weighted normal and we'll kind of see how things are looking. And we'll turn off this number and turn off our smooth shaded. For the most part, looking kind of whatever. Not super concerned. So what I want to do is what I'm going to do here is I'm going to drop down voxel mesh. This is the quickest way to do this. Basically, you can convert things into anything. So if I do convert, VDB convert. Anyone familiar with what a VDB is? By the way, raise your hand if you know what that is. Okay. It just stands for it's basically, well, it doesn't really stand for anything. It's a voxel database. Some people say that, but truthfully, it doesn't stand for anything. It's a file format that is used to store volumes like clouds and things like that. And we can convert this stuff into it. So I could convert this into like a fog volume or an SDF or whatever. But what's kind of better for geometry, I think, is called VDB from surface. Uh, from polygons. Yeah, this one right here. Okay, so this is like what is a VDB. It's all these little like sprites that demonstrate like kind of an ISO surface, like an SDF. But you can also do it as a little fog volume, which would be kind of funny and weird. But if we did that, right, it's gonna be a little heavy. But it's like you have a cloud wall. I mean, this would be kind of useless. I mean, maybe you could do something with it. Maybe kind of fun, especially if you had it like if you had like the seed. You could go up actually in up here, and you could set the seed to like the frame range, and it would kind of move around. You maybe for something that's more motion, that's some kind of more motion vector type of thing that could be useful. But for right now, we just care about the surface because really all we care are doing this for is just because we want to convert this guy back into geometry, right? So if I want to, I'm going to set this to oops. And there's all kinds, by the way. If you type in VDB, there's all kinds of things that you can do here. And also they have their own intrinsic volume type that you can do all kinds of crazy stuff, right? And the explosions, the pyro stuff, it's all volumes as well. So you can make you turn your geometry into volumes and then have that be some kind of collision with your particle effects, whatever. But it's just one way to like retopo in here. Okay. All right. Now kind of play with that ISO value a little bit. And it looks pretty not good. Okay. So I'm gonna go through that now. It's gonna be a little chunky wonky because we're kind of doing that per piece. And I think the ISO value we want to just keep that close to 0. But the added activity we can play around with. But now we have like a little bit more topology across each. And I could play with this value right here, and it would kind of give me a little bit more or less topology. Also, I could back here, I could increase my volume size. So my voxel size, I could make that smaller, which would give us more resolution. And but this can be make things heavy real quick. So right now it's 1,000 voxels per. Remember, we had like 1,000 of these or so. So we don't want to go too crazy because we might end up with like a couple 100 million voxels, and that wouldn't be super fun. But this is doesn't look too bad. Okay, so already that's not halfway. Now you might be wondering especially if you're more of a modeling person, this topology looks like not good, right? The thing is, we're not super concerned about topology in here, and the reason why is because topology matters in two contexts. It matters in the context that things are going to deform. This is a wall. Or it matters in the context of data that you want to put on it. So most of the time when you're poly modeling, you want really nice quads because that's the only power thing that you have. The only way that you can change or affect the normal and how it interpolates is by the orientation of the polygon flow. We can just write normals to this directly, right? So we have a lot more control. Our topology is kind of doesn't matter. We only care about topology as far as like the next operation. But because I may want to do some noise on here, this is kind of trash looking topology. So we could just do a remesh. And this node, like this node a lot, but it's a crasher. So I'm gonna use something called a fast remesh. It's a little easier to control. I'm gonna set the output polygon count. And I think we were doing before, like what would this end up being like? This adaptivity maybe set that to 0. It's like 300 per. Maybe we'll set this to 3,000 per, and that will give us maybe a little bit better. This will kind of just give us like just a 3D equilateral triangles, which generally is the best type of topology for most type of operations, unless you have something that's kind of particular and grid based, or you have like a trim sheet or something like that. So that's kind of not half bad. Okay, and already that's kind of interesting. I could use this as a starting point, okay? And I could start, applying some noise across this surface and maybe bake it to a low poly or whatever. But all this was just something to pull to the side. Again, those labs people, they're really helping us out because they have built a couple things in here that kind of make some of this stuff a little bit more trivial. They have this one thing here. I think it's called edge damage. Yeah. And if I plug this guy in here, it's going to kind of go through this. If we dive in here, we can actually unlock this guy if we really are curious and we want to dig around, or if we want to make changes to it. And it's going to do a lot of the same types of things. It'll use this remesh node, which is essentially these type of voxel nodes. But the cool thing about this is that it's going to do an attribute across here. It's going to give us some controls to get kind of nice wear damage on our edges, which is what we really want. Okay. One thing I will say, we'll just before we walk in there, one thing you could also do, you could just pass all these guys back as a volume. This could be a fun way of doing it, right? And then you have a huge volume wall, and then you could convert it to geometry. And the benefit to that would be that it's they're not all separate pieces. You could have them kind of fused together a little bit. We might have to do a little bit of culling and diluting for that to work, but that's one workflow that could also work. But I think this little lab node is chill enough. So we're just gonna take a look on this guy, and what I want to do is this is 14,000. So I'm gonna make the voxel size just a little bit smaller, not that small. Let's do like point. I think we had a 0.7. That was pretty decent. We need some then a little smaller than that, I guess. 0.5, 0.05. Okay, 0.03. And okay. And we can smooth it. Let's play around with the noise. Let's actually drop down to ones. Let's see, because we're having a really hard time seeing these element size. So basically what's happening right here is that we have a little noise on here. So center noise, that helped to show up. So we're seeing that kind of come up. Okay. It's kind of pitting this rock. That's kind of cool looking. And we can visualize the damage. This gives us a little attribute that can help us. Okay. We kind of play around with that a little bit. But one thing that might help is having just a little bit more distance on this edge. So if I go back here and let's say we do something like that, but also let's go back up. Let's look at our parameters and let's just make these pieces a little bit bigger, say. Let's do this. So this thing will actually pin. I'll set this to 2. Okay. All right. I'll set this to like 200. That way, now let's go back to the scatter node because it didn't seem to change that much. Let's play with the seed a little bit. Okay. And we get different pieces and some big pieces. Okay, not half bad. Another thing too, right now what it's doing is it's scattering these points on the inside, sorry, on the outside walls. And maybe what we'd actually rather want is to have points scattered within. So I'm gonna do something called points from volume. And it just does like creates like this dense lattice of points. And I don't think I need that many points, so we're just gonna make the point separation a little further. We're gonna jitter them about, make them a little bit more random. And this might also give us a little bit better of a distribution of shapes for our cutting here. Okay. All right, but let's turn our wireframe back on. Not that bad. Let's set this back to 1, increase that. We really just want to have like enough of an edge here so that when this volume turns volumetric, we get some nice cutting and pitting up on this. So if I turn this guy off, we have a little bit of edge damage, but let's set this height down, and we could change the noise. This is a Perlin noise, which is pretty chill. But sparse, I like sparse convolution oftentimes for this type of thing. Okay, let's make it a little bit bigger. Let's increase our roughness. Roughness here doesn't mean like shininess. It means like the how like coarse or contrasty the texture is. Uh, Let's see. We can also use those Worley noises from earlier, right? That looked really good. So these cellular noises, they're doing all kinds of fun things for us. That actually looks pretty decent. Let's set this to smooth. Okay. F1. It's Chevy. Doesn't look very good. Chevy shows the same thing. It's a type of cell noise, but it's just a different metric. So it usually looks like a wire. That looks really good. That almost looks like some kind of chipping that we'd expect, right? Okay. That looks decent. Decent. Okay. And what we might want to do, I'm gonna set this to just close that node. I might just add a little bit of like fine noise on it now. But what I could do first is do that remesh. Okay. Sometimes when you have a lot of little nodes like this, or whatever you're using them for, you might just drop those into like a little subnet just to save space and like good little name. Let's see. We had faster mesh, but I can drop another one. Now, funnily enough, actually, what I'm showing you could also work for just like generating rocks. A really similar technique was actually used to generate the rocks that are scattered in the Unreal scene, like right around here. So how this is, let's set this to turn that off, set this to output. This is 60,000, might be a little high. Let's do, oh, I don't know, 7K. Now, ultimately, really, we just care. This is like a high poly, so we could set this up to bake later. Um, or we could break this down to be like instance pieces. So for right now, we're just to walk you through what's going on here. We may not uh, go through every possible step that you might do to like optimize things. This is giving me a little bit of difficulty. All right, there it goes. Right now it's down to 6,000 and it's kind of holding that silhouette decently well. What we can even do is pass on a normal attribute, do that face weighted normal, and we can kind of see those. We can visualize those normals actually. And those will get passed on a little bit better when this comes out. Okay. Versus like turn that off. All right, we can even like pass them on the other side. I'm gonna plug this in here, and we'll let it run through all these little pieces. All right, that's taking forever. So what I'm gonna do is I'm just gonna cut this fast remesh out, and I'm gonna do that on the outside. That way we only have to do the edge damage. And now it's running quite a little bit faster. What is this running? Any questions we have right now? A couple things in the is a subnet like a group or a prefab? Really, it's just a container for nodes. A prefab is closer to a concept, Kyle, that we have called in a digital asset. And in a little bit, I'll actually convert this into a little digital asset, but it's like kind of a little tool that you can reuse, very similar to in Unity's prefabs. Um, oh, so Kyle had an interesting question. B-spline is just a polygon tool, not a NURBS curve. So like here, you can kind of convert data back and forth. You can have something be something NURBS based or like be parametric and then be back into polygons back and forth. So like when specifically actually once this unfreezes, I can kind of show you when I put it into the poly spline, it turned into a NURB, but when I used to resample it, it turned it back into polygons. Okay. Are we forced to use the GUI, or can we create this programmatically and just reference the assets and shapes? So, can this workflow be assessed outside Houdini via server or Unix CMD? I like the way you think, bro. So yes, and that's where the things get super fun. So, you can uh you can do something called Vex, which is a kind of like a shader language that is really powerful to run a lot of this stuff. You can also do this in Python. And Houdini, I open up like the launcher and go to launch, you can launch this from command line. So 100%. And like if you're interested in doing things like that, like you 100% have that power to do that. Even cooler, if you're interested in like agentic workflows, doing like Claude code or something like that, you can also drive this the same way, where you could have an MCP drive and build things in your scene using Python calls, because you can drop down any node using Python, and you can control data using Vex. So that's a good way to think about things. I can tell that you have more of a pipeline TD type of mindset, but yeah, you can do all kinds of very cool things. But I for an artist demo, I kind of usually don't drop right into the coding language. Most of my day is actually like writing, little scripts that run with this. You don't have to. You can do all this stuff visually, but the programming language here is actually really really useful, and I'm not pain and super painful like most most art uh tools like Mail or something like that. It's actually much closer to like writing shaders, but you can, instead of over every pixel, it's over every point or primitive or something like that. And all the attributes that we have, those are the data types basically. So it's like a variable that can pass from node to node, and you can run those and play with those in Python and in Vex. Okay, that took a little while. Okay, wow, 20 million, nice. So depending on like your graphics card and how much stuff you got running, like Houdini can handle quite a bit. Like just render in the scene at one given time. It could probably, I mean, for me, I have like a what is like a 580. I mean, 100 million is when it really will like crash itself. Um, Geometry operations might run into a little bit of, problems or issues. One thing I'm gonna do is I'm gonna cancel that, because I had set this to like 7,000, and like we're reducing 2 million down to 7,000 is going to be a tough job for it. So we'll set this to something like, I don't know, 65K. And that might be a little bit easier for it. All right, cool. While that's running in the background, because this little tool is almost done. I'm gonna give you guys. We're gonna hop into take a look at some terrain stuff, because this is a little bit easier actually. You would just ironic, but terrains are actually really cool, because it's how we do terrains in Houdini. It's this concept called height fields, and height fields are a volume. So we talked about VDBs and things like that. So we'll take a look at a couple different ones. This one's kind of fun. Has like a almost like a little Monster Hunter type of thing going on. But I'm gonna just drop down a height field over here. Okay. And what this okay, is it looks like a little plane, right? But if you see here, it says two primitives, 500 voxels. The middle mouse click on this guy, it's gonna say 500 by 500 resolution and X1. It's like a two-dimensional volume. And so the cool thing about that is you can treat it kind of like you treat procedural approaches in Substance Designer, okay? Where like you can just blend things together, because it's all in volume space. It's all a SDF, it's all height field. Okay, well, it's a scalar field, but similar idea. Uh, you know, and also the cool thing too is if you use Houdini Engine, which is like a plugin that lets you this can these height fields come over natively as Unreal Landscape components. That's another cool thing. Let's first things first that you usually want to do. I mean, we're gonna skip a couple things you might do. You might like set your settings of your size to be a particular size for the landscape, uh, how it's gonna come in. Because again, this will generate as like a height field texture behind the hood. So there's certain numbers that it prefers. It's very close to Pirate 2, but you can check the documentation for that. For now, right now, we're just gonna get into like making things. So just like when you make a texture, what you're gonna want to do is start with like your big macro shapes, and then get into your more small type of micro type of geometry, and then we can kind of get it fairly close, and we can use geometry, but we can also use noise and patterns. And then finally, we're gonna run a simulation to do some natural erosion on it. So I'm gonna drop down a height field noise. Okay. And we have so a lot of this is some of the noises that we were kind of playing around with earlier. So we have this sparse convolution, right? And they also have this like terrain, and they also have fractal Brownian motion, if you're familiar with that, which is basically just like the iterative layers of this stuff. But also we have the Worley noises that we had before. I'm gonna go ahead and set this to 1 octave, and an octave is just the same thing as like a level, like how many of these guys are on here. I like for mountain ranges, and that's what we'll just kind of play around with making. I like for mountain ranges, and what I'll do actually is make this guy a little bigger, 28 to 28. Is I like to start with like a something like a Veroni, some kind of Veroni noise. In this case, we have a fun little whirly, um, and I might play around with its amplitude, and uh, something like that might be kind of interesting. And I can pull a couple of these off and kind of play around with these different shapes, see what we have. This is Manhattan. See, when I said like these could look like circuit boards a little bit, like these other metrics, right? That one especially. Um and but they can be useful. This one particularly, I like Chishebi because it can give you like almost like these natural plateau shapes. So for example, let's say I do a little bit dropping that down. And I can play with the size of this noise as well, like the element size. Let's say we do something kind of like this. And then what I can do is I can do a blur. Okay. Still looking a little geometric. So let's do like a terrace. Compute this range. And let me just keep some of those nice kind of natural drops here. Or reduce the blur just a little bit. And we'll kind of add a lot more of these kind of terraces, and we'll kind of bring this down just a little bit so we keep some of the top part there. So we get some of this maybe natural looking terracing effect. Okay. And you notice that this is kind of red. So this one created what's called a mask. All these other nodes have like a little pin on them. Okay. So I can drag this blur, and I can drop it this in here. And the blur is only going to happen to this part that's in red. Okay. So I can maybe set this only a little subtly so we get a little bit of that aliasing off. Okay. Cool. And what I can do is now I can maybe drop down another noise. And for this guy, I think sparse convolution is great, but I'll go with like a much smaller size, and I'll make the amplitude way smaller because we really just want like some high frequency kind of stuff and just a little bit of warping. And I can even go to post process. I think in distortion we have some gradient warping that can be somewhat useful here. Not that high. 0.2 maybe. All right. It's all right. Uh, maybe run this guy down just a little bit. And what we could do is we could have like a separate type of noise applied, depending on if it's terraced or not. So I could go ahead and invert this mask, right? And I could run that mask in here. So now that this stuff is only happening up here. And then maybe I have a separate one where the mask comes from up here, and we can play around with like maybe some different settings so that we get maybe like crazier warps or different types of maybe less octaves so that the stuff is maintained a little bit differently, or maybe just a different noise. Let's say maybe that's a funny one. Let's try whirly noise. It may be less octaves. This one may not work, but let's just play around with it for a little bit. Eh, I'm not feeling it. Let's see. Alligator's fun. Uh, I don't know. You can also kind of stretch them out a lot, one way, one direction or another. So, this might be one way we could do something maybe interesting here. I don't know. Sometimes you just kind of play around and experiment. Now, already that's kind of interesting. That's something that looks a little bad, right? But it's one of those, a pattern like this actually could work if like you do some blurring and do like another noise on top of it. Let's stretch that out a little bit more. I think actually could be interesting. A little reroute node right there. All right, not half bad. Interesting, but we're starting to lose our initial terrace, so we want to maybe blend some of that back in. I think it's combine. There's a couple different ways to do this. You can do volume combine, and you can also do height fill because they are just yeah. I don't like to do it, so I like to do it with the volume because you can just use volume mix. What I prefer to use because you can do like two different pins. Let's see. We were kind of here. Let's set. Let's see. We do this noise right here. I think what we'll do is we'll do another pass right here, but instead we'll set this to default, and we will run like a simple let's drop down a new one. Do like a simple like sparse convolution noise, and we'll kind of blend these guys on top of each other. That's funny. Let's see. We want to be like that. Yep. And we want the element size to be. The element size is fine. I think we want to just drop this guy down. Yeah, that's good. 12 is fine. Let's drop this. Let's play around with this guy a little bit more. Maybe that's not half bad. That's pretty chill. Eh, that could work. And we kind of do this. We kind of just multiply, maybe not multiply. Blend is the one I prefer. And that way we're just getting so we kind of have that bass noise. We're just going to get a little bit, a very little bit of that like downward striation, right? Um, that could work. Okay, so we have this one. This was the mask here, which is the mask that's driving a lot of these things. What we could also do is just play around with this mask a little bit. I could expand this mask. or I could shrink it. And maybe sharpen it a little bit so it doesn't have such a tarpon, a such a fall off. But this is like really similar to the type of workflows you would do in Substance Painter. And actually, you could do cops as well. You could use like the image compositor, which is really similar to Substance Painter. Just a little bit, it's a little bit newer. It only came out like only a year, maybe a half ago, so it has less nodes. And you could convert those to the images into height fields. That's a workflow that's also Gucci. Okay, not, it's something. Almost gives you some kind of asset kind of vibe. Uh, come back here and let's play around again. No, this whole thing is just non-destructive, right? I think what I maybe want to do is come back to my initial noise and make the amplitude a little bit greater. That way it's almost like little mountains. Okay. And we'll come back to our terracing. Not half bad. And we'll kind of come down a little bit. And what I want to do maybe is before we terrace, what I'd like to do is heightful remap. So I just want to like remap this range. Really what I want to do is I want to take keep this range right here and take the output minimum and kind of one thing you maybe do is just play with this. So essentially what I want to do is instead of having like those big holes, I want these to actually just come into like a resting space a little bit more readily. Bring those guys back up. And that could work. And what I might do is pull this back just a little bit. But do this before the blur. That way things get smoothed out just a little bit. And then we can run our terraces, repeat this range again. And we will run down just a little bit. Be fine. Let's run to the bottom. See how our noises are coming together. Okay, that's we have little valleys in between. Interesting. But it can be a little bit harsh. So maybe we could just swap this whole thing out for our whirly noise that we had to begin with, which I might just bypass the remap just because that was set to a particular one. Or what we could do is just like we could mix these guys together or apply one on top of the other. Let's see. Let's go this way. Again, all this thing that we've been doing here is adding. We can also subtract or multiply or blend as well. So, there's something right there. Or we could, it's almost like a Photoshop stack type of effect. We could just blend between these two and get like something halfway, which much. Maybe get a little bit higher. Let's try to get those. That was really funny. Recompute the range. And let's just try to get a little bit of some valleys in there, maybe. That's not half bad. And we run all the way down. And not half bad. But let's go ahead and clear this guy. Clear his mask. Now already it's getting close. It's like, it's whatever, but it's a little, it's a little 2003. Um, but here's like the really cool thing is that you can get like something that's a decent set of base shapes. I wonder actually, I think I'm in one of these, maybe I think this expand one probably, or we probably just weren't terracing any at all. Uh, there's a lot of extra controls we can do for these terraces. Let's compute. Let's just make the terracing happen like low to the valleys, like these were like human-made terraces, for example. And let's just increase the number. Okay. It's okay. Kind of give us some weird looking weirdness because I think we're a little too close to the ground. But we'll try just something like that. Maybe that'd be interesting. Hmm, not have fun. Now, obviously, this is really giving us the 2003 vibes. But the cool thing is when we drop down an erosion pass, it's really gonna do some magic. So I'm gonna turn this off from freeze at frame just because I think it's funner to watch it go a little bit. Now, what we'll do is we'll set this to visualize. We'll have Hatfill visualize so we can set this up. And really, I just care about like what we're gonna do. Turn on our frame range. Okay, we'll just turn this guy down, all right, so we can watch it go. Uh, okay, right there, it's kind of cooked for like a second. And when I middle mouse click, now we have a whole bunch more volumes. And really, these are all masks. It's going to output a bunch of these different masks for us. And right now, we haven't really done anything, but we can kind of visualize what some of these masks look like. So we have like this one here called flow, right? Which is like where debris would kind of come off. We have like one here. That's just a height map, right? We have one called debris where things will clump up. Sometimes you get like a water one, depending on what settings you set in here. But I'll just go ahead and set like these flow direction ones, and I'll also maybe get rid of some of this green so that maybe it or make this green like a more appropriate color or something like that, and make this white a little bit more predominant. Maybe make this green down here. That's a little visualization, right? Does not need to be super interesting or perfect. Uh, maybe we'll make this guy like a little desaturated, but also we can output this as a texture as well, or like a tinting map. Way too saturated. Okay. Way too blue as well. All right, that's not. That's getting closer. Okay. Wow. Um. Any case, let's go ahead and just set our frame range to like 20 and just hit play. Yeah. Okay. And if we right here, and we're getting kind of some break-ins, and that's helping quite a bit. So we could play with this a little bit as far as like what's given us. So like we have a lot of weathering forces, and we have a decent amount of this cut angle is like it's a kind of a powerful setting. So if I set this to something like this. Now you can also just do like freeze frame, meaning that like it's just gonna do the whole thing by itself. All right. So kind of every time you make an update. Uh we could increase the weathering force there, see if we get something kind of interesting. Um, erosion size feature. That's kind of like a almost like a scale for this, like a similar to like noise scale. But really, what's happening in this is like during every frame inside this guy. This is another tool. This is like Houdini's. This goes into like a context called called DOPS, like Houdini's Niagara, and they're simulating a bunch of particles moving down against the height field and then scraping a little bit away, and they have attributes connected to them. And they have a bunch of different versions of this thing, like precipitation ones. Really, all these do is just set like attributes to like tell it, there's going to be more or less rain. Let's see, layer bindings, simulation. I think rainfall coverage is a pretty decent one. But that one's ugly. Let's turn that down. But really quite quickly you can get something that's fairly decent looking as far as like the result here. And right. And maybe if I could ever choose fun or interesting colors. This I think is from the flow because we have way more rain. That's interesting. So this mask right here, that's all just from increasing that rainfall coverage. If I set this back to 0.1, right? You get way less of that, right? And these are useful actually because you can take these maps and you can export them out. So not only are they cutting in and doing something to the geometry, but you can also use them for blending of textures in something like Substance Designer or in something like, well, if you want to do more advanced stuff like that in Designer, but in like Unreal, you can use it to drive your master materials specifically. Uh, yeah. In any case, I'm just gonna get rid of that. That way we kind of see a little bit more of it. All right. All right. Not half bad. Okay, so that's fun. That's like kind of how you would play around with these terrains. I'm gonna walk you through a couple of the other setups that we kind of built, just so you guys can just kind of see other approaches. But these won't be kind of built from scratch. So this one we started with I think a Veroni, just straight up, and then we decided to bring in some geometry. So there's a test geometry which is like this template head, and I kind of just like moved it in the scene so it was kind of like this. And they had this height field project, so it kind of just project it into the height field. Okay, I'll turn off this skylight and turn it back to the headlight. Uh, and then I can also project a mask, and I'm going to use that mask to just blur this edge right here a little bit. I'm going to pass a blur across, invert that guy, pass a blur across everything else. Okay, clear that. And we just have something kind of like this. We're going to pass a little noise on here. Oh, that's one I didn't really do. Like high field distort's pretty useful as well. It's kind of like passing a noise onto the UVs of the whole height field. So this one, you can kind of very quickly get something that looks not half bad. Um, and this is with erosion. Um, so okay, decent enough. For what we have in the scene in a real, we have kind of this setup where you can do this a bunch of different ways, but this is one way maybe you could do it. So I started just by tilting this. Um, and I think for the terrain noise, I used like a Chevy because it gives me this kind of shape. We did blur, we did distort, and we did flow fill. This one's kind of cool because this node has it's almost like a solver, but without doing any particle simulation. It kind of just figure what it does is it figures out like the first and second derivative, basically the rate of change, and it kind of outputs that as a mask. So usually it's going to look like things slowing down. Okay. Um, And what's cool about that is that you can use this to, because like if I just like clear this guy, clear the mask, right? Right, it hasn't changed, right? It doesn't do anything by itself. But you can use this mask to like push out geometry. So for example, I'm just going to shrink the mask a little bit, or rather I'm going to shrink. This is with the blur, but instead I actually just swap things around where I set this to height. So instead of just, that's a really interesting thing. You can blur, but you can also just blur the height, or you can shrink or expand just the height itself. So this kind of has the effect of kind of just pushing out along that topology. So maybe set this to a set dome light so you can kind of see some of the difference between those two, right? And we still have that mask. So I flipped it around and I kind of uh sharpened as well. And maybe we'll set this to like the physical sky. But that makes it really easy to kind of see what's going on here. And I inverted it, and then I just use this to kind of blur. And now I get like kind of these, almost like these mud falls. Okay. Um, okay. Which is, basically it's just some kind of, I think I actually have one way to make it even easier if I could just do something like this and run the clear in here. And you can just use this as like a gradient if you compute range. I prefer to have it just kind of swapped around a little bit. And I could even like run, we have that, I think it's called flow in this one. And you could have that be like that. And that's like an easiest way to kind of get like a feeling for um what that's kind of doing. But it's way faster because you didn't have to wait for the solver to change or anything because you're just using it almost like a poly extrusion. And so this could by itself be kind of useful. This could be like a side cliff or whatever. But what I wanted to do was I kind of just wanted to have this so I had a bunch of really broken up different sections. And I remapped it. So with the remap SOP, one thing that's kind of cool is that you get these little curves, right? And so I could just see, keep my range. And I could just control this like to control the height, but I can also do something like this, right? And now I've created a valley. Okay. Now, in all truth, there might be some other ways to do this because this is still like going the direction it was going before. So it's kind of like flowing up, but it doesn't really matter because I'm going to do an erosion kind of towards the end. So it really is just something that we can do to kind of get some kind of base pattern that has decent and interesting cuts and setups. But right, that's something that you could do, right? And that's like a little valley. It's almost like a decent like little gameplay area. Uh, and even then, you could do like another remap, right? Let's say you do another. All right, this kind of reminds me actually of the terrain from like Halo 4, that like little desert um level with like the vehicle, like the huge vehicle. Although terrible fucking game. And the same kind of idea where we can kind of like that. And that might even create like a natural riverbed, right? In any case, you can play around and do all kinds of things, but you can turn from one thing to another. That's one of the benefits of something being volumes and volumetrics is that it just kind of plays with itself really, really easily. Whereas like with topology, you have to deal with a little bit of making sure you have the right data, the right groups to do an operation. Here things just work out. Anywho, we did this right here. we kind of, I think, this is a really cool one called Mask by Features. And what it does is you can get like a little mask on here depending on something about the your terrain. So I could get peak my range. I could just get the peaks. Let's say we actually chunk this guy onto like one of our mountain examples from earlier, right? So this could be our peaks or our valleys, and I could right. And this might be something where I could drag this again. Uh, now this can be used to get like slopes, for example. And I could maybe do something kind of like this. Okay. And maybe height, where I kind of cut this out and like maybe even a maximum. So I have a band here. And I do this. And instead of replace, I can make this multiply. So now like this mask right here only shows up here. And maybe I could do something unique or interesting with this. But it just kind of creates masks of interest. I could use this mask to terrace. I could use this mask to apply a particular type of noise. One thing that this one's kind of like AO. This is kind of useful sometimes. Mostly I'll use this maybe for like a coloring pass. I mean, it's kind of neat. It can sometimes give you like the tops of mountains, which is useful sometimes. This one's kind of cool. It's not as useful, but it is cool. So it's kind of like a sun angle. Very rarely you're gonna have a game where this will make sense. In a linear game where like it's not an open world or whatever, where it's like fixed geometry, then this can make sense where like there is something that's happening directionally on the map, so you get a mask. It's kind of cool. Yeah, so these are really great. And we use them quite a bit here. So we have that right there. I'm just doing a little bit of cutting of this guy. And or we do a little erosion pass. And that's kind of it. So what we have there is we have like a basic terrain, and we can pass that out to be exported. Over here is a number of different color works. You could, in this case, what we decided to do, we actually visualize some of this, is really what we've created is a bunch of masks. Okay. So we have that mask, we have this mask, right? This one. And really what I'm going to use these for is just to blend highly palatable textures. Now for the size of this terrain, because this is the type of thing which would be, really more of a like a linear kind of canyon type of thing. We're not doing this as complicated as you could. What you can actually do that's even more crazy is you can have these exports drive the material layered parameters. Rather the landscape parameters, right? So, and if you're doing this over Houdini Engine, the same thing. But in this case, I kind of just export these out as textures where I map these different named masks. So if I middle mouse click, you can see all these different named masks to the different channels of texture, and we exported those. Additionally, what we did was, again, we can convert anything to anything else. So we got this little mask, right? And then we did we dropped down here and we did this convert to height field. This part doesn't really matter, but this convert to height field, we made it into geometry. Okay, so now this is all polygons. Okay, and what's cool is that it keeps with it the masks. Okay, we did a couple things here to maintain scale and make sure that everything exports the same way from the way that the landscape components in Unreal are like put their pivot on the corner. So that's why we're kind of using this match size to kind of move ourselves around. And really what I'm interested in doing is using this color to delete. Okay. All right. So this is a delete stop, and it lets me delete by an attribute, essentially. Actually, sorry, this one right here. And I just did at CD, which is that's what they call color diffuse, the name of color here. So it's under like 0.1. Now we have all these little chunks. Okay. And we have this is VOPS. It's just another space that you can play around with like attributes. So you could do things in Vex, and so Vex is kind of like this programming language, like this. For example, this is Vex. But you can also do that. Everything that's a Vex operator that you could do in that programming context, you can actually also do in this what we call VOPS, Vex operators. It's this like it's almost kind of like a shader graph because Vex is kind of like a shader language. Vex stands for vector expression language, and it's essentially like a shader language written for the CPU because there's certain types of geometry operations in the creation of geometry so that you can only do on the CPU because you have to pull from a file or make something on a file. But they want it to be able to in Houdini think about things like you do in a shader context where you can think about ranges and do something across an operation of points or primitives the same way you would do across triangles or pixels or anything in a compute shader. But you can start out here to learn the basics. So we just add a little bit to this mask here. We're gonna do our UVs here. What we're gonna try to do here is we're gonna create inset meshes. Okay. A lot of times this is a very common technique in games where people will do like a terrain and they'll have like little geometries they'll put on top, right? Sometimes they'll chunk these out like I'm doing. Sometimes they'll use kits. In our case, a lot of this was inspired by the work from the good old people at Ubisoft on Far Cry 5. They did a very similar technique here. We did fast remesh. Okay. Smooth wireframe, and we can kind of look down here and we can see that the smooth wireframe, much better topology. Now, on this side, is something very interesting. This is some reference I have in here, and I kind of wanted this kind of striation pattern. So how I got that was I made a line. Okay. And it's just this line is just what it sounds like. It's a SOP that by the way, if I ever say SOP or COP or whatever, that stands for node, right? It's just operator. These are surface operators, right? So like SOP. This is it's just like a straight polygon. Okay, that's what a line is. And you can make it longer and shorter, and you can add points or whatever, right? Okay. Okay. What I did with this guy is I set some little expressions in here. These are script expressions that essentially got the bounding blocks to this node right here. Okay. And made its origin be the bottom of it and its length be the top of it, right? So what that means is that like it's aligned with this this whole guy. Okay. Then I resampled it. Okay. I just added a bunch of points, like 27 points or so. And they're just spread about. Okay. They're just kind of spread about on here. And then I did this point jitter. It's kind of like just randomly kind of jitters the points, what it sounds like. And I set the axis values to 0. So it's only up and down. So it kind of just makes them show up kind of randomly, whatever. And I kind of randomly sorted their order. That helps a little bit with this. And I made an attribute called class from their intrinsic PT num, which is just like the number of their point number. Okay. And now on this is what they call the color node. And so if I drop down a color here, this is like how you could like basically set up like vertex colors and things like that. Turn off all these numbers, right? So I'll turn off this UV as well. If I like set this to like purple or pink or whatever, right? But it has a lot of other cool features. Like you can set things from attributes. So like this is a ramp from an attribute. If I happen to have an attribute on here where I have like this height one, I'm not sure if it's going to be useful or not. Probably not because this is like right. So that's kind of neat, right? It gives me a little gradient. Okay. Let's see what else we got. Sediment. That one, I don't know if that one's going to be interesting or not. Let's see, that's kind of interesting. but you can make things, right? And you can also do random from attributes. So if you have like some, but this has to be kind of like a an integer value, a random ID, and kind of like over here, what all these little numbers are. Okay, so what I've done, if I set this to random ramp from attribute, I think I originally played around with random from attribute, and this works too. But and you can do this, but I found that like what it does is it gives you like a random color. So ultimately, what I want to do and why I'm doing this is because I'm going to take this since it's the same height. I'm just going to transfer this data, and because it's kind of laterally across, it's going to come across as like little slashes. So like we do that, but I don't know. This is kind of it's like Willy Wonka. Now I could maybe desaturate whatever. So I decided instead I want to control. That's what I did to begin with. Control this with a ramp. So I've set the range to be it's that same minimum and uh I think I just like set a number here. This is I think probably the bounding box uh maximum divided by two, but I just kind of played around with it. I think it is that divided by two. And I kind of just put some fun colors. And what I did is I for each one of these, I just used the color picker and went to my concept art or my reference rather, and that gave me a bunch of these little gradations across this spline. And it might be kind of hard to see, so I'll just do a sweep here so it's a little easier for you guys to see what's going on. Well, that's funny. Yeah, because it's like they're the points. Yeah, so basically we're getting like this type of gradation, right? And that's essentially going to give us our bands. Okay, when it tries to interpolate that across all this stuff. And they're kind of harsh, but that's fine because we can do some blurs and stuff like that. We use a group. There's another group setting here, include by edge, and this unshared edge just gets all these points right here. I want to get this as a group because I'm going to set a again. I'm going to pass this striation as vertex color and have it multiply over some tiling textures. So since I'm sending vertex color, I might as well send something in the alpha usable. And what I want to do is send this mask around here that's on like the edges of these inset geometries because I can use that mask to help this better blend in with the terrain. So in here, basically I've set this to alpha. And the viewport, when you set something in the alpha, it does this thing. So I'm just going to go ahead and delete that so that we can actually see what's going on. Okay. So essentially what's going on here is that I created entirely another pattern because I kind of want to get the vibe or the look of like you have multiple different striations from like tectonic movement and like stuff like that you'll see sometimes. So we had this original one, okay, and this second one was really just an entirely separate technique where we got a noise. In this case, it was an alligator noise, and I am setting the frequency to 0 in the X and Y and like very small in the up. So that causes it to kind of stretch out infinitely left and right. Okay. If I were to just say we just bypass, and this is bops, for example. So this is all this you could just do straight in Vex if you really wanted to. And we're just gonna visualize this one. Oh yeah. Why are you yelling? You know, this happened to me the other day. I'm not quite sure why. It kept I think maybe I have to update my graphics card. It keeps being painful. For some reason, because it was running fine until I actually wanted to wire anything into it. So then it decided to be itself. But that is, gotta see if it's came back. Ultimately, that's fine though, because what I can do is I can bind it and then use there we go. That's kind of funny or weird. There it goes. Okay, so it decided to come out. Uh, yes. See, just check out what this noise looks like. And like with the yeah, well, so you see, basically, if I were to come back here and I were to take this noise right here and set it to like 0.05, so it's like the same size as the rest of it, 0.05. This is alligator noise. It's based on Varroa noise, but it's like kind of like more bally in shape. But it has a kind of fun little fall off. But because we get that little striation there, that worked. And that's just another way you can do the same type of thing. And basically, what I did was I took that and I put it through a ramp, and I just did the same kind of thing where I chose fun colors based upon what I had here. And then remember earlier, I had like I believe earlier I had brought in or I had did this little mask by features. This one right here. I think further on down right here. This was from the debris pass of the terrain. So this is where things have kind of fallen. I'm gonna use that as a mask to kind of blend these two different things together. And so that's like a attribute on here called debris, right? And I can just get that by name, uh, import debris, right? And I think I mix it with like a noise. This was like a Perlin noise and so on. And I use that as my mask. And so here's like that final mask. Just a little bit. Let's make sure we're in the right spot. So we have a kind of a little bit nicer of a mask. So this Perlin by itself, just because it's these kind of big pieces right here, and we have more of these like cutty fall off pieces together. You know, we kind of play around with it. We get something good, and eventually we kind of pass this into color. So we have like it cutting these two different shapes, but also we also have something where this is the edge, right? That edge value. I'm taking the just the red channel of this stuff, right? Which is just you could do other ways to grayscale. This is just one way I decided to get this to grayscale. I'm multiplying this right here. I'm gonna use this to displace this. So part of the reason I want this is because I'm gonna use this to push out the geometry. So if we jump down just a little bit, and we'll bring this with us, we'll subdivide this guy. Okay, and we're going to use this triplanar displace node, which basically will push out the geometry. On this op itself, we're using displace scale, which was that grayscale that we had set for this. And I will set this this color back. And eventually we get to this point right here where we have some decent geometry. Now this was created for kind of a nanite context. So we have kind of these, you know, where each one's kind of pushed out itself. And we kind of chunked it up. Now this part you could, because it's a little bit smaller, so I just manually kind of cut this up. But you could also have this procedurally done as well. If for a very, very big terrain, you would want to do something like that where you have it cut into individual little pieces. When we go into error wall. When we go into Unreal, we have these pieces, and I'll go ahead and if it ever does this to you a little bit, like it gets a little slow because you like left it. All you gotta do is like reopen the map and it'll be itself. Usually, actually, let's stat unit. Let's see how we working. I was having a hard time. Let's get the GPU memory to flush. Come on. This is not a hard scene to run. But Okay. Any case, we have this right here. You'll notice that one cool thing is that if I zoom in with my, you notice that we have a little bit of a dither blending kind of thing. And that's what that mask was for, really. So if I hop into this master material, we'll kind of take a look at that just real quick because this is a cool one to know. We have like some textures here. I think these are like some of these we made I made in the course. Some of them might be like a mega scans. I can't remember. This one I think we make this one. I can't remember. No, we make this one. I can't remember. I remember now. So kind of just have this texture and I have this like material function that just makes builds a little material here. Multiplying it by the vertex color we had coming in. And we also have a little switch here that's for debugging, just seeing the color by itself. But the really cool thing is we have this alpha, and I have this alpha offset. And I'm pumping that into, and what might even be useful is to turn on that little preview thing. I wonder, do I pass in the alpha? No, I usually don't. So let's say we do this. All right, so this is where that kind of alpha showed up here. And I'm going to multiply that by the dither temporal AA. So what that is, sounds fancy, it's really not. It's just like a small, tiny texture in here. Right? It's literally like this super tiny texture. I think it's like 64 by 64. All right. And it's just like taking screen space projected pixels. So actually, if you notice as I like zoom around, it kind of whoop, 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 whoop. That way it's not really dependent upon the UVs of the model or whatever. And since it's so tiny, it's going to cause a pointillistic effect. That's what dithering is. And I'm going to multiply that by a value called PDO. And it's going to go into the PDO input. And what PDO is it's this kind of really cool feature of the engine called pixel depth offset, meaning that parts of here that are like white or have a certain value can be pushed in depth. Those pixels can be pushed in depth. Now that's really interesting because how the renderer works is something called a deferred renderer. Okay, right? Things are included behind things, right? And we wait for every single thing to draw, and then we process all the buffers separately. But because we've done that, we can actually now say for this object or for this material, we're going to take this pixel and we're going to push it behind another thing. And why that's helpful is if we do this with like this pointillistic effect, it can give the effect of like something kind of blending in because we're actually pushing some of those pixels behind the landscape with this wherever this mask is. Okay. And I'll go ahead and just pass the dither in so you can kind of get a vibe for what's going on. All right. Now the sometimes it's gonna be a little strong, so you might have to play with it a little bit. It's still lit. You'll see that you can see it quite fine. So that's great and all. We're gonna go ahead and turn this back on, and that's like an old school method. So you get rid helps kind of get rid of this hard line. One thing that's a little tricky with PDO is it doesn't like to play super well with lumen and lumen and nanite stuff together. And these are nanite meshes, so you might run into a little bit of stuff. But for a lot of things, like some of this like sand, right? It does pretty decent. Like right here from the system, looks really good actually. And what's cool about this is it's cheap because you didn't have to like sample this tiling texture of the landscape again and blend it or do anything like that. It just kind of worked TM. That's cool. The last thing I think I'll show you guys is two other things. So we have all these rocks, and these rocks are all running in PCG. And how we got those was back in Houdini. kind of up here with our canyon, we have a lot of data still, like our debris data. We can do what's called height field scatter. This is kind of like the scatter node that we saw earlier, but it takes in a height field. Wow. And specifically, you can use a mask, like a name mask. Okay. So density using mask layer. And I got to plug my mask in. And instead of using mask, what I can do is use one of those computed maps like debris or settlement. Okay. And it's going to give me all these points. All right. Sick. Okay. And what I can do with those is I can just, they have something here that's actually kind of useful called PCG Labs export, which will export like a, CSV format, like basically a data table of its rotations and like what meshes are involved into it. If you pass that, that's pretty much good. But you can also just, let's say if you you're just want to create some inset geometry again, or have something that's coming over in some other method besides PCG. You can also do this thing called copy to points, and this is like one of the most OP nodes in here, where you can basically, let's say, oops, this is points, and let's say we drop down a toy or something like that. One thing I'm going to do to help with performance, because if we have a lot of points, let's say right here, this is like 1,000 points or so, right? One thing you can do is they have a setting here usually where you can just you can only output the points. That helps a little bit. Only yeah, keep incoming terrain, get rid of that. We don't need that. And what we can do something called packing. And what this will do is it will just make our incoming mesh, right? It'll make it what's called a pack primitive. And it's going to treat it, it's going to display it like normal, but it's going to treat it like 1 point. So this whole thing's going to run a lot faster. See, they didn't even care. So we have all these little toys, and they're all aligning on here because this guy has picked up the normals. And I'll hit D here so that we can kind of visualize those normals a little bigger. Visualize geometry. And they're always moving stuff around. Oh, it's in guides. All right. So okay. So it's picked these up. And basically what's going on here is like the copy to points data on the points themselves are used to do every single thing that's copied to it. So you can author like an orientation using like the an intrinsic attribute called at orient, and that's a quaternion. But you don't super need it. If you have a normal, Houdini will kind of just build that itself. So in this case, these points, no mouse click on them, have but this node actually also outputs an orient, so that's even better, right? And that puts these all right here. Another thing too, let's say this was rocks or whatever. You can do all kinds of crazy things. You can add data here. So like one thing you may want to have is some kind of random instanceable data, some kind of color ID, right? And there's things like that in the engine already, like instance IDs, but maybe for one reason or another, or you're on a proprietary engine and it doesn't support that or whatever, you need to be able to bake that into the mesh. You could do some kind of randomization. So just like we had color SOP before, we could drop this right here, and we can do like random from attribute. Random from attribute, and the we could do position. We could also do like at ptnum probably. Actually, we probably do the same thing where we did with class, but position works decently enough because it's just going to give us a random value, right? Another thing that you can do is they actually have something here called attribute randomize, which can give you like a random attribute of any kind. You can just name this foo or whatever, and you can give it just a range and tell it if it's a vector or whatever, right? So that's one thing. So by default, it sets the color and it goes 0 to 1. So that works out really well actually. So we have a bunch of little colored points. And also, you can make these a little easier to see um by set them to like discs or and one cool thing about setting them to discs is that shows you the kind of the orientation from its normal. Or you can set them to lines, or you can set them to lit spheres, just like what different ways of visualizing points. So I just like to set some points and make them a little bit bigger sometimes for when I'm working on terrains. Anywho, um, oop, and I'm gonna go ahead and turn the material off, and you see we have a bunch of different colored guys. And that's one fun thing you can do is copy to points. So that's like how we did a lot of the instancing of the grass and the rocks. Um, for the landscape material, okay. What we'll do for that, it's kind of the last thing I'll show you guys before we take some last minute questions. So I'll go ahead and turn off these canyons so you guys can kind of just get a see for what it is. And maybe try to turn off some of this grass. I think I may have also did like a quick paint or something like that. Yeah, with the grass paintbrush. Which for me, I always like to do. You can mix destructive workflows and non-destructive workflows, but ideally you want to have them on like not in the middle, right? Like so, like sometimes you can. I used to have a art director at Tech who really liked to do a lot of iterations on the base shape on a height field, and we would then take that as input and we do all of our operations on that terrain. And we just set it up where like there's two separate maps where like we're not overriding his data, but we're always fetching some fresh landscape to run on. But then at the end, sometimes you can do some stuff. Just keep in mind, it's hard sometimes to have that like if the input data changes, this grass is gonna be floating, right? So this unlit, so we can kind of see different stuff that's going on here. We have a couple different painted layers, but we have kind of like a little bit of some different masks here, okay? And they didn't need to be crazy, but they just enough to kind of give some color variation and to blend with. Okay, so click this guy. We also have an RBT that's coming out that's being used to blend in like the grass a little bit. All right, landscape material. Okay, there we go. Now this guy's gonna look a little complicated. He's not. He's just really simple. So we had this landscape, sorry, rather this material function earlier. I'll just show you what it is really quick. It's really simple. Material functions, by the way, if you don't know what these are, any of the blue ones, they're just like a self-contained set of nodes for materials. Really, this is like a cheap and simple. I would not recommend doing this. This is like just more simple stuff. Like this is all world triplanar mapping. You could necessarily get away with triplanar mapping, but ideally, it's going to be expensive because it's 3 samples. There are ways of doing this type of thing with 1 sample, but that's going to vary depending on what kind of texture you're using, if that's going to work or not. Because there's what's called cheap triplanar, but it has a little bit more harsher fall offs. So what if you don't know what triplanar is? Basically, the idea is unlit that like well this one's kind of hard to see. Maybe I'll set this guy to like a different number, like 12, right? So it's kind of blending itself on all these different sides a little bit. I'll set this guy to even smaller, maybe 64. I wonder why this one's stretching across the top. Kind of interesting. No, I'll probably because it's only previewing the top thing right there. So if I preview this right here, so you see, there's no UVs. It's just it just gets the world position in like the Y, X, and the sides. Projects 3 separate textures and blends them based upon a based upon your vertex normals. Okay. So super quick in case you've never seen this before. 3 samples. Okay. We get world position, which is just a position, a coordinate system, just like texture coordinates. This right here, this is just scaling it, this, right? And these are just different planes. Okay. These are just like the different planar projections. All this is just a bunch of BS so that you can turn the alpha on and off if your texture at an alpha. And then we're going to blend these based upon a normal. Okay, so your vertex normals, these are just all the pointy vertexes. They visualize this as color because this is the positive, positive coordinate. This would be the negative coordinates, like 3D coordinate. You know, think about this. If we look at one of these, well, I didn't mean to make that into the perimeter. Stop. Okay, we right click this guy and start previewing. We'll kind of get this because we're just looking at the red channel, which is the XX, right? So this is just the values of the pointy arrows that point in this direction, basically, a little bit. We do actually, now there's some pointing in the negative direction, but they're black absolute value, and they use cheap contrast to kind of like give some bend here. Now that's a blend, and they're going to use this to blend on this white part right here, that plane for the XY. And that's basically all that's going on here. It is use the vertex normals, or you can put in your vertex, your just a normal map, right? And they use this to just get these little masks that help them blend the planar projections. That's all that's going on. It's not great because it's 3 samples, okay? And that's times 3, so that could be heavy. This is like a little thing. This is like a thing to control how strong the normals are. That's not important. Nanite, in my experience, does not like the way it likes to do like displacement is kind of weird. So I found that like the best way is to pass, let's say you're passing like a height map or something, like some kind of displacement, you want to push things out, which I'm doing with the all of the cliffs. It kind of wants to be recentered. So this is like how I do it, where the height value is coming through, you know, displacement value, and they're multiplying, and you're dividing 1 by half and subtracting. This is what I found. Just found this on some forum, and it seemed to be the best way to get displacement working in a controllable and reasonable manner, similar to how tessellation used to work. Okie dokies. That's just how that's landscape. That's just a layer. Okay, very simple. Back to the actual material. So we have a bunch of these for different types of textures. We have like a plateau texture, some muddy cracks textures. That's the one kind of looked at earlier. Fun looking gravel. I think most of these, I think all but the cliffs and the sand, I think are like, yeah, I think these guys, and I think the cracks we build, but I think the gravel and the plateau are mega skins. And we have you know, like some tinting stuff and the tiling size and the normal controls. Over here are those different masks that we output. So you know, we have, this is like kind of the bottom. This is like some kind of inclusion data, and this is like some curvature. So it looks like AO actually, and AO inclusion and curvature. This one right here was the features map, which I think was just like the different passes from the erosion. Like this is the flows and the debris and so on. And this last one, I think I just called it gradient, and this is like big passes for like the top, the middle, and then like the base. And I kind of pass these guys out to detailed names right here. And some of them I use alpha offsets on. And basically I'm just blending these different textures using these different masks. It's really that simple. At the end here, I use some of them a little bit, like I don't know if I'm gonna even be able to like really preview this texture in here, but like the macro texture, which I think is like the first one in this one right here. I use these to I just multiplied the base color and it tints it a little bit. So the detail and like the curvature in the flow, you can see a lot. So like when you're in this scene and you see like a little bit of color variation, right? From like from this, it's just because I took the underlying layered materials, which the materials were mostly blended based upon like this cliff feature or like this bottom river one was what we got this like cracked set of textures with. Um, right, slopes, plateau, valley, streams. Why name these different things? And then I just like did a little bit of like color variation and blended them back on or off with these with these like little settings. So we could come in here and doing it in the instance is kind of cool. So we can kind of control exactly how much of this or how little of this we get. So we see we're getting quite a bit of it, kind of make it a little bit less, right? And it's basically just an alpha offset, which is a fun node that helps expand masks. So that way, you don't just have to be stuck with whatever you got from Houdini and re-export or whatever, but you can do it a little bit live in the shader. Or have it ran by like gameplay if the river dries up or something, right? Um yeah. Let's see, albedo. And so there's a lot of these are kind of fun. Like this macro one. One thing is it's being a little slow to update because I think we're updating the RVT, so it's going to be a little. All right, so that one's kind of fun to play around with, especially with all these because all the grass and all the rocks as well, they all pick up the base color because I'm outputting that into a runtime virtual texture. All right, so that they actually blend a little bit. So they have their own texture, but if I were to play around with these a lot, you can see that right there is it calculating and passing down. The little squares is the bilinear linear filtering of the RBT. Uh, if I set this back to like 3 or something like that, should be fine. Or just set it back to the default, maybe like 3 0 to 1. All right. Yeah, but that's just some different ways that you can build an environment like this. Okay. I think I'm gonna go ahead and set this in unlit. Or a couple patient questions, and we'll get to those. And then we will I think we'll have maybe we went a little bit over, maybe by a little close to an hour. But we'll do 17 minutes, I guess, of questions. Let me just see what we have here so far. Could you export that as an image? My guest Kyle was talking about like the site field. Yes, and in actual fact, we did for this workflow. But you can also just export it kind of dynamically with a Houdini engine as an HTA. By the way, that would be something kind of like this, where let's say we'll use this example before we do all this stuff right here. Say this was our edit, like that. This is our little wall generator. I'm going to make this a digital asset, call this wall generator, whatever. Okay. And let's go ahead and create that. I did not spell that correctly. That's fine. And the cool thing is when you have like a little node set up like this, you can just drag it in here and it will auto link those settings. And now I can just type in wall and general, and this will build that little tool. And I can also like import this into something like Unreal. Okay, getting WoW Stoneathon mountain vibes. I guess there's left frame way of sculpting that's allows for iterations and modularity as opposed to zero. The truth is, you can go either way. So a lot of guys I know they like to Zebra, they like to sculpt in ZBrush and go back and forth. There's actually some really great tools to let you auto hop back and forth, like a Z for Houdini is a really good one. Um, the thing is, you just want to get good at everything and just do the fun parts where it's fun, right? Sometimes what I like to do a lot of times if I'm making textures or a base terrain, I'll do a couple passes in ZBrush, and then I'll try maybe take that base. I'll maybe do that for my macro base sometimes, especially if it's very hero asset oriented, and take it to designer or take it to Houdini. So like you just want to do the fun part where it's fun. Um, now, from a workflow perspective, sometimes there is a benefit to just having everything super procedural. But when you're doing your own thing for portfolios or whatever, just do what's fun and what looks good. So it's a shader language like HLSL. It's a shader like the shader style language. Technically, it runs on the CPU, Brandon. So I'm guessing that question is about Vex. Explicitly, a shader is a program that runs on the GPU, but it's styled like that. So it's the same syntax, and you can think about it. Basically, works the same way. Then you go back and forth with plugins, and it's highly multi-threaded. So it is parallel. It's highly multi-threaded, but again, it's on the CPU. So it depends on how many cores you have in your CPU, right? But if you have you have a Threadripper, you get some benefit, but it's not like your GPU where you have millions of these parallel cores. You said you hated math in high school and college. How did you rebuild to encompass the knowledge you are very motivated to share with us now? I've looked at swarm, path voting, type logic, and trigonometry. This seems very multi-dimensional and phased math. Well, that's cool, brother. So for well, I'll tell you guys is Brandon, yes, it's being recorded right now. And I think they'll put it on LinkedIn, but I also think that you guys will have it emailed to you. So you can do pretty well just playing around, but it helps to know what you're doing. And there's two things I'll tell you. I'll tell you three things. One, as far as swarming stuff, what you want to look into is something called voids. Is probably the most common technique. Another thing you want to think about when you say multidimensional, we're making 3D art here. So we're always doing multidimensional stuff. So that's not really a big deal. Vector math is pretty easy. The thing about it is on the math side of things is math is just taught really poorly, and I would say honest to God, your average high school math teacher doesn't really understand math. Okay, if you want to really understand math and get it, because most people think math is about numbers, and it really isn't. Math is also most people think math is real. It's not that either. Math is a language, just like English. It's a language to describe relationships between objects. That's what it is. Okay. So anything that you can think of, anything you can put a label on, and some description between those two things. So data sets, and that's X and that's Y and so on. It has nothing really to do with additions and so on. If you want to kind of open your mind a little bit to it, abstract algebra is a really fun topic to look into. Another really fun area is Gershner waves or fast Fourier transform. Really, where I decided I needed to kind of pick up the math concepts. Where one of the other instructors here who also teaches this term he was the first person I ever taught. He was my first mentee when I did a private mentorship. His name is Hisham Uchum, and he was finishing bachelor's. And in Europe land, they make you do a thesis, which is awful. And I think he went to Howest, and what he did for his thesis was an FFT ocean. And if you're not familiar with that, that's one of the most difficult types of implementations for water. It's basically the ocean they have in the type of ocean they have in Titanic and Waterworld. And the math involved there, Fourier analysis, it's the type of math you would never see. And by the way, analysis is big boy word for calculus. This math you would never see unless you were a pure math master's or student or a senior or something like that. But it can do some super cool stuff. You're seeing Sea of Thieves, and you can get these huge cool swells. You can only do that with FFT. So the math unlocks actually understanding what's going on unlocks some pretty cool stuff. And once you actually do kind of bite in, it builds on itself pretty crazily. That's that same technique, that fast Fourier transform, in those Fourier analysis. That's also what's at the core of Midjourney and any diffusion model. So like you can deeply have a deeper understanding of machine learning techniques and how best to use those in a workflow that might be appropriate for it. And not just like, oh, slap your fingers against a keyboard for an agent, but actually build your own bespoke training, or your own model that you've kind of directed a little bit from research paper. A lot of your job, especially if you start to get a mid levels, is reading, be able to read a research paper and convert that into something that's going to run well, right? And actually knowing a little bit of math helps. Okay, any questions about anything that we've kind of covered so far? Can be anything in this demo, anything about technical art. Um, there are 16 watching individuals. I'm sure someone has a little thought or question. Let me ask a question. Did was this kind of followable to a certain degree, or was it a little fast or but exciting, or fast and unexciting? You can give me an emote for that, by the way, if you're super shy. Okay, I have a couple messages here. It was a bit fast, but it was fun. All right. Let's see, what else do we have? I made something similar in Unreal 5.5. Very cool. Very cool. Fascinating stuff. How well does this work with Godot or Unity or Unreal similarly? So Houdini engine, there's Houdini engine for Unreal. There's Houdini engine for, like, with the installer. You can just download these plugins and, this all works with Unreal, with Unity out of the box. I believe there are integrations for Godot, but also, with something like Godot or a proprietary engine that maybe doesn't have its own landscape component or whatever, right? You can just bring this over as geometry or chunk it up, right? And the same type of shaders, it will work exactly the same. At the end of the day, we're all executing zeros and ones. So yeah, it worked the same. There might be some particular features in Unreal's material setup that you might not be, like PDO may not be there. Some of the lighting things may not be there, but more or less the same. What are your thoughts on generative AI? How might the tech art field change as it gets adopted more? I have a pretty I'm probably one of the foremost experts on AI in tech art, especially. I use a lot of a lot of my job is like driving procedural systems with AI. So like training AI to use like procedural tools that I built, or the inverse. And I think that the whole thing is that, like, most people, like the 90 percentile of people about AI just have no clue what they're talking about. It's not gonna it's not gonna, no one's losing their jobs. No one's like the doomerism, it's marketing, okay, period. It's like we could spend like 2 hours. There's nothing about job loss makes any sense. If you really just sit and think about it, it doesn't make any sense. That aside, it is really cool technology, and you can do some really interesting, neat things. But the cutting edge workflow isn't really like talking to a chat panel. Okay, the cutting edge workflow is more agentic, where you have a bunch of agents that you've set up particular context for, and they're making files for you. They're creating doing unit tests. They're basically like air quote coworkers, and you're kind of wrangling with that. In some places, very little of the code is manually typed. But you're kind of like it's almost like you're driving cats a little bit. One thing that's cool is like, if you imagine if you had like infinite time, okay, and you could like go into a bubble and like you worked on a team where you had a dude who could just take infinite time, and anytime you needed like a small little tool that was just an inconvenience, you know, um, you could just have that immediately. That's kind of what it can do for you. So you can use these things to build small disposable tools that you might only use for like a week. You can the amount of things that you can do um, is pretty crazy and phenomenal. And that's just pretty basic workflows of just like working with LLM based agentics things. When you start getting into like the deeper level of creating synthetic data, so something like um, a diffusion model, okay, or any neural network, like they are built on data. Like proceduralism with something like Houdini is perfectly built for this stuff because you can use something like Houdini, and a lot of studios do to actually do this type of thing. Like there's a place called Applied Intuition. They work on self-driving cars, and they use Unreal and Houdini to create a bunch of synthetic data sets of cars driving through cities, right? I've seen like similar stuff, for people at Lockheed Martin or all kinds of autonomous kind of places. So you can build a data set in something like Houdini using procedural techniques, and then use that to train. I'll give you a small anecdote on this. This won't be Houdini really, but just give you an idea of what you can do with this that might be useful to a team. So if anyone's familiar with like the studio Gearbox in the Borderland games, really talented tech artist by the name of Ryan Smith is the technical director over there. And he shared this really cool thing on his Twitter or his LinkedIn or something. They have like a really great asset pipeline where the Gearbox games, these Borderlands games are kind of this particular graphic-y comic book style. And how they do that is there's a decent level of like shader stuff with like edge detections and all kinds of stuff, but there's also just normal artist base colors and so on, right? And they have a workflow where the artist will save out different layers of their base colors, but also just like black and white masks and so on of like their their graffiti, hand drawn stuff onto the characters. And they just have a huge asset library of that because they've made, I don't know how many Borderlands has made, like 6 of these, okay? And there's a technique called style transfer where if you give a neural network, a convolutional neural network, two good samples of things, Fourier analysis essentially is a technique to basically, if two things can have a comparison, let's say y and x are on a graph, and I'm going to tell you there's some cool little squiggly line. Now, I don't know what it is, okay? Right? There's a function here, okay? How might you find that function if you don't know what it is? Well, if you're just in grade school, you might just draw it. You might just plot out points, okay? And it's not really going to give you the function, but it's going to give you something kind of that approximates it. It's going to give you little points. Fourier analysis is the same idea, but instead of using just points that you're connecting, we actually use functions. Fourier analysis, you use complex value trigonomic functions like sines or cosines, and you just stretch them and you add them together to make and deform to the shape of a function. So a neural network, when it's back propagating in the context of something like an image generation, it's trying to map, let's say in this case, one style to another. That's what style transfer is. In the context of, let's say, like you type in something to Midjourney, the prompt from the LLM gives the convolutional model a style target, and that's what it's trying to map that to. And it's using Fourier analysis for that, which is basically, you guys notice like when you use those things, it'll be a little blurry, and then it will like iteratively kind of get better. The reason why it does that is because essentially it's starting at a Gaussian noise. So it's like evenly distributed, which if you know a little bit about math, you might know that like cosine waves and like a big hill like this is kind of the same thing. It's something called the Euler identity. So a Gaussian noise, which is a normal type of tiling noise, can be converted or turned into any set of cosines. So when you use Photoshop, you have what's called filters, right? You use like a brush, or you use like high pass filter, or you do like a blur or whatever. How that's done behind the hood is something called a convolution. Convolution is this idea of like you have a set of like numbers in a box, three numbers in a box. And like for a blur, you might have like a Gaussian blur. You might have like 0.9, 0.1, 0.1, 0.1, 0.2. Like it's like a little triangle. And you put it on top of a pixel, okay? And you multiply that decimal value by the color of the pixel, and you add everything up and you divide by the number of pixels. Essentially, you even out the different colors, right? And that's why it blurs, right? And you do that for every single thing. And they'll have different patterns of these for every single operation that you can do in Photoshop, like sharpening or edge detections or whatever, right? It's just a different set of these things. But usually you're just doing the same box of numbers across every pixel. And a convolutional network, you're finding essentially what the network's trying to solve for is what is the perfect set of numbers for that's different. Let's say a different set of 3x3 grid of numbers for every single pixel. Every single pixel is going to have a different one to turn this random Gaussian noise into the photo of the cat, because that was the style target. And it's going to do that one time, and it's going to iterate again and again. That's why it goes from blurry eventually to something. In the context of style transfer, if you have two targets, you have enough data, you can actually be really reliable, where at the end of it, you have a program. So in the context of computer programming, really we have inputs and we have an output, right? A game, the inputs your fingers and you type around, okay? And the guy moves, right? And that's the output, okay? Machine learning is not like that. Machine learning is the inverse of this idea, where instead of having the program part, the algorithm, that's the part we don't really know how to do. But instead, we have the input and the output. We have the input data and the output data. And the math there is just to map those together. So it's kind of the inverse of this whole idea. In the context of what Ryan Smith was doing, they had all these textures of these graffiti masks, okay? And they wanted to match a style target, okay? But they also had data that was going to come from the mesh, which is the normal map, for example. So we had a huge bucket, thousands and thousands of normal maps, and the thousands and thousands of this corresponding mask. And it was able to train a small convolutional network to create a little program that when in Substance Painter, the artists bake their model, immediately they'll get that map as a starting point, and they can play with the seeds and play with a couple sliders, and they can get somewhere to begin from, because starting from an empty a blank slate is kind of difficult, but it was very bespoke and specific to their data and to their pipeline. It was just another thing to help the artists. The artists don't have to use it. It's just something to make things go a little quicker. And especially for like some of their less hero content, it can really get the day moving a whole lot faster on the surfacing side. That's an example, and a little bit of a detailed breakdown of how that works behind the hood, of how you can use these techniques really, really in the weeds, to do all kinds of fun, crazy things. Okie dokie. Is it better to use Houdini, or is fab assets and foliage mode good, since Unreal is changing so quick and getting better? That's ultimately that's like the bad context. You want skills, okay? And you want hireable skills. Downloading things off fab and using the foliage brush isn't that great of a skill. Okay. Now there's cool things that you can do in Houdini. Sorry, in Unreal, like PCG is more, or I would push you more towards if you want, just build on that skill. But Houdini is a very desirable skill. But really, a lot of this course is designed to be fairly software agnostic, where we're teaching you techniques that could be used kind of anywhere. You learned all this self-taught? Yes. I never had a senior. I was either the only tech artist or the lead tech artist everywhere I've ever worked. Part of the reason I like to teach. Okay. I think we're good. Any last call on questions? Okie dokies. 1 second. All right. I'll give you about 2 or 3 minutes. because we are a little bit over. By a little bit, like an hour and 5 minutes. But I really do appreciate everybody for staying a little longer than it was. Okay. So I've been fascinated by, thank you, Ria. I think that's pronounced correctly. That's one thing, especially if I'm teaching, if I'm one of the instructors. Uh, right now, I think we just hired on 3 new tech art instructors. So sometimes I'll teach your courses, or I'll come in for like a substitute day. Uh, but we kind of break them up. So if I'm pretty terrible with names. So if I mispronounce your name, I want you guys to correct me immediately. Okay, so I have been fascinated by cartography from an early age to now. In the past, I used Photoshop to generate in-game tile sets, mod at the time for Ultimate. Are you familiar with technique like this? Yeah, that's really cool. You know what I would tell you to look into if you're interested in things like this? A really cool technique for you to play around with is something called wave function collapse, which is a technique. I mean, there's actually some stuff in Houdini for it that's really fun. It's funny. I think it's a metaphor, and it has nothing to do with quantum mechanics. It's just a metaphor for how this function is written. Uh, but no, it's just a really common way of doing model synthesis. Um, so let's see. This is the original paper. So this it can be done in 2D and 3D. So basically, you give it like a set of tiles. In this case, it's 2D tiles, and you give it a target style, and it will kind of create something like this. So it's used for map drawings. This is like how they want the map to look, blah 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 blah, and it does the thing. Kind of generates out these. We don't really have time for me to walk through like how this one works, but it's a fun thing to look into, and it's really great. So there's a lot of really fun games that have this in them. So like probably the one of the funner ones was some stuff from this the dude who did like Bad North. No, not this one. Because that guy is a really great technical artist. Because I think his game built that way. Like all these were kind of built using wave function collapse a little bit. This one's in 3D. This is like I think from Matt Marion 42, which was the first person to really do this in 3D and left it on a blog. But really, they have Side Effects Labs people did a version of this. So if you're really curious, there's actually like a built-in version of this stuff in Houdini that you can like tear down and play around with, and they have like a little tutorial you can walk through and download their stuff, and it works with the Houdini engine, so you can like generate new stuff for it. So yeah, I mean, I'd play around with something like this, but you can be really clever. You can build outdoor environments as well. Yeah, really common way of doing procedural generation. Okie dokie smokies. Um, is your technique foolproof that if there's something that is rough or correlated, correctable from the generation, how would you fix a small area or edge that you would have to impact? You can make these techniques a little bit just non-destructive. It all depends on how you build it in. Here's the thing. You want to kind of build things in a way where everything's procedural. It does it because putting too many like manual edit kind of fix contexts can just really increase the complexity. At some point you just gotta trust it. Trust the vibe and get it to a point where it's strong enough. But no, this wave function collapse is really common. It's in a lot of big games that are procedurally kind of generated, or like roguelikes. It's really common in roguelikes a lot, actually. Okay, guys, I appreciate you guys. Oh yeah, by the way, if you didn't see that in this, that's a really good thing. Thank you for reminding me. The easiest way to get a hold of me is on Discord at Carlos, Karlaws. uh, you can reach out to me on LinkedIn. I I may or may not get back to you. Sometimes I just don't see it, but I'll usually get back to you day of. or the next day if you reach out to me on Discord if you'd like to. Every time I come back to 3D, I end up doing comfortable Maya, Photoshop, Unreal. Some people are mixed in, but yeah, maybe. If you want to pick up one AI tool, I'd say play around with Comfy UI. That's a really good one. It's almost like the Substance Designer of image-based models. It's like a little node network that you can like mix different models together. Uh, Very cool. Well, I appreciate you guys coming. Have a great rest of your day, and this recording will be sent out to you guys in case you want to try to follow along with anything in this demo.